15.177 involves this Geneva mechanism, which is composed of two disks. One is rotating at a constant angular velocity of 8 radians per second in a counterclockwise fashion. The other is composed of a disk that only moves when this pin that's connected to disk D gets into one of these slots. It occurs whenever the line here, the angle is 120 degrees. It will cause this disk right here to rotate until this slot comes down into this position right here, and the pin comes out again 120 degrees over here on this side. We're to find out whenever this is set in arrangement here, whenever this angle becomes 150 degrees, a pin will be inside here, and we're trying to figure out what the omega spin is and the alpha spin for this disk is. I'm going to repeat down here a drawing of O, P, and B. So here's O, P, and B. My x-axis, both capital and lowercase, is right here, and my y-axis, both capital and lowercase, right there. We know this angle is 30 degrees right here. We know the velocity of P is perpendicular to that line right there. We're going to calculate what R sub P is based on the fact that we know L, which is 2 times R sub D, and R sub D itself is 1.25 inches, so L is going to be 2.5 inches, and we're going to use the law of cosines right here to find out what R sub P is, and when we do that we get 1.549 inches. I'm going to store that in 1. We're going to use the law of sines to find out what this angle phi is, and so when you do that, you'll end up with phi equal to 23.8 degrees. I'm going to store that in 2. Now the next thing we're going to do is we're going to relate the velocity of P, which we can get by doing omega D crossed into R sub D. There's omega D crossed into R sub D. R sub D is got a unit vector of minus cosine theta I and a plus sine theta J right here. And that's got to be equal to V sub P prime. P prime is a point that you mark on the disk right here, and you look at what that velocity is in space. Well, that's an omega spin crossed into R sub P. R sub P is a unit vector cosine phi I plus sine phi J. And then V sub P slash frame is just some value U times cosine phi I plus sine phi J. All right, so what we're going to do is we're going to take the x parts on one side and equate them to the x parts on the other. The x parts right here are going to involve this sine theta, because you got a k crossed into j is going to give you a negative I, so we're going to have minus omega d rd sine theta. Over here, k crossed into j is going to pull us a negative sign, so we'll have a minus omega s rp sine phi right there. And then you got your u cosine phi. You do a similar thing to get the y parts, and you get this expression right here. This is two equations with two unknowns, the two unknowns being omega spin and the velocity of P with respect to the frame. That's what I call U. Simultaneous solutions yields omega spin equal to negative 3.81 radians per second, which means it is going clockwise, which you can see from the mechanism it would. And U has a value of minus 8.07 inches per second, which means that it is approaching the origin, meaning that it's moving in this direction. Okay. Next thing we're going to do is calculate the acceleration of P. Well, we know for the absolute acceleration of P is going to be it's moving around at constant speed, so it's just going to be a centripetal type acceleration. So what we have then is A sub P is minus omega D squared times R sub D, and there's the unit vector associated with the vector R sub D. And then the A sub P prime is that footprint acceleration, and it's got two parts, an alpha crossed R plus omega crossed R. Well, here's the alpha crossed R term right here. The omega crossed R term will reduce down to minus omega squared R sub P, and that's omega sub S. And then you got your A sub P slash frame. We don't know what it is, but we know it's got to be in a cosine phi I plus sine phi J, either plus direction or minus direction. And then A sub C, A sub correlative is going to be 2 omega S crossed into the velocity of P with respect to the frame, which is this U cosine phi I plus sine phi J. So there it is repeated. And what you do out of this then is to get the x parts collected together. So the x parts over here is going to involve plus omega d squared rd cosine theta. The x parts here are going to involve the k crossed into the j term. So you'll get this. This would be omega s squared times cosine phi. There it is right there, times the R sub P. This would be A sub P slash F cosine phi. And this right here would be K crossed into J, so we get a negative. and there'll be a minus 2 omega SU sine phi. There's minus 2 omega SU sine phi. You do the same for the y parts for this equation right here, and you get these terms right here. You do a simultaneous solution on this because you got two unknowns, alpha sub s and a sub p slash f, and you'll get alpha sub s then a minus 81.4 radians per second squared k, which tells you that that's a clockwise acceleration, and the magnitude of a sub p slash f is 69.8 inches per second squared. I say the magnitude, the value of it is this, and since it's a plus sign, that indicates that the a sub p slash frame acceleration is actually away from the origin,